Let's look at the case of an object which is traveling in a circular fashion with a constant velocity v. At this point, when along the circumference of the circle, let's say its velocity is represented by the vector vx. And at another point here, let's say the velocity is vy. The magnitude is the same, but because the direction changes, vx and vy are different vectors. Because remember, a vector is represented by its magnitude and direction both. So if the direction changes but the magnitude doesn't change, still Vx and Vy are different vectors. Now the question is, what is the difference between Vy and Vx, and how do we represent Vy minus Vx as a vector? In other words, what gets added to Vx so that it becomes Vy? How do we draw Vy minus Vx as a vector? Now we know that by triangle law of vector addition, let's say we have a vector A and then we have another vector B shown here. The addition of A and B, A plus B, is this vector. You see that the resultant vector starts from the tail of the first vector. In our case, Vy is the resultant vector. Something gets added to Vx to give Vy. So Vy is the resultant vector, and the resultant vector's tail starts from the first vector's tail. They coincide. So let's translate Vy. We are not changing or rotating it or changing its magnitude. We just translational motion, and let's coincide. Let's place it in such a way that the tail of Vy coincides with the tail of Vx. So it comes somewhere here, and this vector is Vy. Now to complete the triangle from Vx, head of Vx, if we travel towards the head of the Vy vector, now this yellow line is Vy minus Vx, or rather this line is Vy minus Vx vector. So this is what gets added to Vx to get Vy, and if we add, it is very obvious, Vx plus Vy minus Vx, the Vx's cancel out and we get Vy vector. So this is the line with which we can represent the difference between Vy and Vx as a vector. Thank you.